Okay, our topic today that is on derivative of a quotient. Last time we discussed on derivative of a product. So this time we are going to discuss derivative of a quotient with the formula u over v that is equal to v du minus u dv over v squared. So if we are going to look at here, we are going to square the denominator. Then you will have denominator derivative of numerator minus numerator derivative of denominator. This can never be interchanged. So we should follow the format. Unlike with the product, where in the product we can choose which one we are going to differentiate first. But here we start with derivative of u, derivative of the numerator first. So we will have our examples. Okay, the first example, that is equal to y is equal to 2x minus 3 over x plus 2. So derivative of a quotient. So we will have dy dx is equal to d dx 2x minus 3 over x plus 2. So first step here, we have, so this is our u, this is our v. Okay. So from the formula, note, from d dx, okay, dy dx of u over v, that is equal to the square of the denominator, then v d dx of u. Okay, so you will have minus u d dx of v. So that is the formula. So therefore we will have x plus 2 square. Okay, because that is square of the denominator. Then we start with denominator. So x plus 2. Then we will have d dx of 2x minus 3. Then we will have minus 2x minus 3. Okay. Then we will have d dx of x plus 2. Okay. So after that, we will have, okay, so we will have derivative of, okay, we start with x plus 2. So we are going to find the derivative of 2x minus 3. Derivative of 2x, that is 2. Derivative of 3, that is 0. So we have 2x minus 3. Derivative of x, that is 1. Derivative of 2, that is 0. So all over, we have x plus 2 squared. Okay. So after that, we are going to multiply 2 inside. So we have now a form of x plus 2 times 2 minus 2x minus 3 times 1 over x plus 2 squared. So we are going to multiply 2 inside. So therefore, we have 2x, 2 times x, 2 times 2, so plus 4. Then we have 1 times 2x, that is positive 2x, times negative 1. So we have here negative 2x. Negative 3 times 1, that is negative 3, times negative 1, plus 3. Okay. So we have x plus 2 over squared. So therefore, we have If we will have 2x minus 2x, that is equal to 0. That will be cancelled out. So therefore, our final answer, that is equal to 7 over, okay, x plus 2 squared. So this is now our dy over dx. So dy over dx. So here, this is still dy over dx. So this is now our final answer. The next example, that is y is equal to x over the square root of x squared minus a squared. So dy dx, that is equal to d dx of x over the square root of x squared minus a squared. Okay. Take note that square root, that is raised to the exponent of 1/2. So we have here, so the first form, we have over, if we are going to square the denominator, so we have x squared minus a squared. That is square root, so that is raised to 1/2. Then square of that. Okay. Then, so you will have 2 over 2, that is good as 1. Then we have here denominator, so x squared minus a squared. Okay. Then we will have d dx of x minus x d dx of the square root of x squared minus a squared. So therefore we have, okay, so we will have the square root of x squared minus a squared. Then we will have d dx of x, that is 1. Okay. Then we have here x. Here we have derivative of a square root of x squared minus a squared. Because we have an exponent, so we are going to start with the exponent. The exponent here, that is raised to 1/2. So we start with the exponent, so 1/2. Then we have x squared minus a squared negative 1/2, because that is 1/2 minus 1. Then after that one, we will have d dx of, okay, derivative of x squared minus a squared without exponent. I hope do you remember that one. So denominator here, x squared minus a squared raised to 1, because 1/2 times 2, so that could be 1 over, so that is raised to 1. So we will have that one. Okay, we have now a form of the square root of x squared minus a squared minus x times 1/2 times x squared minus a squared raised to negative 1/2 d dx of x squared minus a squared. So here we will continue. So this is square root, so we will have x squared minus a squared raised to 1/2 minus x 1/2 times x squared minus a squared negative 1/2. Derivative of x squared, that is 2x. Derivative of a squared, that is 0. Because a, that is a constant, because our derivative is x, that is dx. So we will have that one. So our denominator, x squared minus a squared. So we can simplify this further into, so we have x squared minus a squared 1/2, okay, minus 2x squared, 2x squared over, okay, over, that is 1/2, so you will have over 2 over 2. Then you bring this down, this could be positive, so we will have x squared minus a squared raised to 1/2. So this is now all over, okay. So your denominator is x squared minus a squared. So this is now our form. We have a form of x squared minus a squared raised to 1/2 minus 2x squared over 2x squared minus a squared raised to 1/2 over, all over, x squared minus a squared raised to 1. Okay. So therefore, we are going to, this one is our LCD in terms of our numerator. So we will have that one. LCD, that is 2x squared minus a squared raised to 1/2 times, okay, times that one. So you will have 2x squared minus a squared raised to 1/2 times x squared minus a squared raised to 1/2. Okay, then you will have minus 2x squared. Okay, so all over, so all over x squared minus a squared raised to 1. So therefore, you have the same base, x squared minus a squared, x squared minus a squared. So if you have the same bases, you add the exponent. So that's the reason we have 2x squared minus a squared, that is raised to 1, because 1/2 plus 1/2, that is equal to 1, minus 2x squared over, okay, over 2x squared minus a squared raised to 1/2 times 1 over x squared minus a squared. Okay, take note, in our algebra, if we have division of fractions, so we have here, this is your A, this one is your B, this one is your C, and this one is over 1. So, and your over 1, that is your D. That is, if you will have A over B, divided by C over D. Okay. The form then, that will be equal to A over B times D over C. So that's the reason we have A over B, okay? A over B times D over C. So this one is your C. For over 1 here, that is your D. So that's the reason we have that form. So we have now a form of 2x squared minus a squared minus 2x squared all over. So you will have 2x squared minus a squared raised to 1/2 times x squared minus a squared. So if you're going to look at here, we are going to multiply 2 inside. So you will have 2x squared minus 2a squared minus 2x squared. Okay. So all over, okay, we have the same basis, x squared minus a squared, x squared minus a squared. This is raised to 1/2, this is raised to 1. So we are going to, if we have the same basis, am, an, okay, and our laws of exponents, we are going to add the exponents. So that's the reason you will have am plus n. So that's the reason we are going to add 1/2 plus 1. So we will have 2, okay, we have x squared minus a squared raised to 1/2 plus 1, that is 3/2. So if we are going to look at here further, 2x squared minus 2x squared, that is 0. So that could be cancelled out. So what is being left here, we have negative 2a squared over 2x squared minus a squared raised to 3/2. So therefore, if you are going to look at that one, we can cancel out 2. So the final answer, dy over dx, that is equal to negative a squared over, okay, this is raised to 3/2. So your index here is 2. So we can write that one as the square root of index is 2, x squared minus a squared, then that is cube. Okay, that is the form. So this is now our final answer. So that's it. Okay, we have our example number 3. Y is equal to 3 over x to the 5th. So we are going to find the derivative of ddx of 3 over x to the 5th. So if you are going to look at this one, this is derivative of exponent. But then, if you are going to bring x to the 5th up, that would become ddx of 3x negative 5. So you have an exponent of negative 5. So derivative of that, we have 3 times negative 5 x negative 5 minus 1 ddx of x without exponent. So this would be cancelled out. So therefore we have, okay, negative 15 x negative 5 minus 1 negative 6. So our final answer, that will be equal to dy over dx equal to negative 15 over x positive 6. That is now our final answer. Okay, the next example, that is y is equal to 2x cubed plus 4 over x squared minus 4x plus 1. So dy dx, ddx, 2x cubed plus 4 over x squared minus 4x plus 1. So we start with x squared minus 4x plus 1 squared as your denominator. So we are going to square the denominator. Then denominator, x squared minus 4x plus 1. Derivative of numerator, 2x cubed plus 4 minus 2x cubed plus 4. Derivative of the denominator, x squared minus 4x plus 1. So, after that one, we have x squared minus 4x plus 1. Derivative of 2x cubed plus 4. 2x cubed, that is 6x squared. Derivative of 4, that is 0. Minus 2x cubed plus 4. Derivative of x squared, that is 2x. Derivative of 4x, that is negative 4. Over x squared minus 4x plus 1 squared. Okay, we have now a form of x squared minus 4x plus 1 times 6x squared minus 2x cubed plus 4 times 2x minus 4 divided by x squared minus 4x plus 1 squared. So we are going to multiply 6x squared inside. So you will have 6x squared times x squared. So you will have 6x to the fourth. Then we have 6 times negative 4. We have negative 24x cubed. Then we have 6x squared times 1. We have 6x squared. Then multiply 2x cubed plus 4 times 2x minus 4. So we have 2x cubed times 2x. So you will have 4x to the fourth times negative 1. So that's why we have negative 4x to the fourth. Then we have 2x cubed times negative 4. So we have negative 8x cubed times negative 1. So we have positive 8x cubed. Then next we have 4 times 2x. So we have positive 8x times negative 1. So we'll have negative 8x. Then we have 4 times negative 4. So we have negative 16 times negative 1. That's the reason we'll have positive 16. So we are going to combine like terms. X to the fourth, x to the fourth. We are going to combine x to the fourth and x to the fourth. 6x to the fourth minus 4x to the fourth. So we have positive 2x to the fourth. We carried out the higher value. What is the sign of the higher value? That is positive. Then we have negative 24x cubed. We have plus 8x cubed. We are going to combine the two. Negative 24 plus 8. That's the reason you will have negative 16x cubed plus 6x squared minus 8x plus 16 over x squared minus 4x plus 1 squared. So this is now our final answer. Our final answer, that is dy dx is equal to 2x to the fourth minus 16x cubed plus 6x squared minus 8x plus 16 over x squared minus 4x plus 1. Okay, we have here some practice problems. You are going to find the first derivative. So for number 1, that is DDS of s squared minus a squared over s squared plus a squared. So if you are going to look at for this first practice problem, your variable here is s. So you are going to look at the denominator that will indicate what is the variable of the given equation. So the variable here is s, and treat a as your constants. For number 2, that is ddt of 5t over 1 plus 2t squared. So here, if you are going to look at here, the denominator denotes that the variable of the given equation is t. So therefore, t here is a variable. For number 3, that is ddx of x over x minus 1. If you are going to look at the denominator, this denotes that this denotes that our variable is x. Number 4, that is find the derivative. Y is equal to x squared plus 3x plus 1 over x squared. So variable here is x. Number 5, y is equal to 2x to the 4th minus 1 times 5x cubed plus 6x. So here, our variable is x, and you are going to use derivative of a product for this one. For number 4, derivative of sum, x squared plus 3x plus 1, that is our lesson 1. Then number 6, that is y is equal to x cubed over 3 plus 3 over x cubed. So you are going to use lesson 1 for this one, because x cubed, as what we have in our example a while ago, you can bring x cubed up and make that as a negative exponent. So you try to answer this one if you have some difficulty in your problem solving. If you have some difficulty in solving this problem, so you can just message me or make a comment. Okay, thank you. So next video, I will be discussing on implicit differentiation. Then after that one, we will have trigonometric differentiation. Then follows the derivative of logarithmic functions. Okay, thank you.